This piece of melamine-based insulation foam is about 3 times more effective per weight than traditional glass wool insulation. And contrary to industry standards, it's being applied to this yacht, Yacht Zero, using non-toxic glue sourced from the upholstery industry in order to eliminate the thermal bridging from traditional insulation mounting pins.
The big idea is just if the half of your consumption on board of a ship is caused by the air conditioning, which you can influence by the insulation part, then you really want to go far to do an optimization over there. Where we have a lot of energy consumption on board of Zero, it's really interesting for us to do more research how we can bring that energy consumption down. And there we really pushing boundaries, pushing ourselves, pushing suppliers, manufacturers to get really to the next level.
That's Eduard, the project manager for the build, which is the world's first emissions-free sailing yacht of its size, with an all-electric propulsion system and a strict design objective to be as efficient as possible with every drop of energy used on board. And we are Foundation Zero, a platform that promotes the use of renewable energy by openly sharing insights and data from a range of innovative engineering projects. To help with this topic, we spoke to the R&D manager from a company called Pyrotech. They designed the melamine-based insulation product called Sorbamol, which was used on Project Zero.
The critical property of acoustic and thermal materials is actually not density, which is very often something that people don't realize. The first thing when you ask someone, what makes an acoustic absorber perform quite well, they'll tell you, okay, higher density, when in actual fact that's not quite true. The most important property of the acoustic and thermal materials is actually their flow resistivity. So the amount of the rate at which they allow their airflow through them. The Holy Grail is something that weighs nothing and has basically no mass. So vacuum is an obvious choice. Unfortunately, vacuum is not something that is very easy to install around the vessels. We are fairly limited in terms of materials that can be used in the marine industry, very simply due to the fire requirements that the materials need to meet. So there are very limited amount of materials that can comply with the IMO fire standards. And these in general are either non-combustible or the likes of melamine, polyamides type of foams. What we can do with foam-based materials, they are really microcellular materials, so they can, control the flow of air through them a lot better, and the restriction of the airflow through the material is directly comparable to their efficiency in terms of thermal and acoustic properties.
If we use a melamine product, it's much lighter than a rock wool or glass wool solution. So by using a melamine product, we can increase the insulation value and still keep the weight budget in control for the ship build. Weight-wise, this is roughly 9 kilograms per cubic meter. And typical, if you have a glass wool, you start with around 30, sometimes 25, but around 30 kilograms per cubic meter. So that's roughly 2.5, 3 times more weight. So actually, it's now turning the other way around. If you have typical, normally, let's say, if we just have 30 kilograms per cubic meter on weight budget for the insulation, and we have here now 10 kilograms of weight budget, we can increase 3 times more the insulation thickness and therefore also the insulation value. Well, a typical way of installing insulation on board of a ship, you're using insulation pins which you weld on the hull, and then you start foaming around it. So you stick the pin through it and you connect it to the hull. But if you look a little bit deeper, a small pin does create a heat bridge, which is for one pin not really a big deal. But if you have more than 30,000 of such pins, then it starts counting. So we figure out that we would almost lose 1 kilowatt hour on heat transfer by using those pins. Think what really is the takeaway. Don't think too small. And don't think in problems, but really think and rethink and solutions, and be open-minded. That's really the takeaway. People think, by example, if you think it's just, we get so used to, by example, just a pin to use it, and nobody gives a care about the pin. But if you then think, yeah, 30,000, that makes really a difference.
This story illustrates what can happen when industries begin to pay real attention to small pieces of the energy efficiency puzzle.
So I think in general, the drive is very much to for any project to reduce its carbon footprint, and you certainly see a drive in terms of electric vehicles, electric vessels, or hybrid to one point or another. With these sort of setups, the weight is quite critical, and so making a project most efficient in terms of not only initial installation but running ongoing costs is something that is being more and more important these days, not only in the marine but certainly we've seen it in transport industry, we've seen it in the building industry. So it's something that's becoming getting a lot more focus these days.
There's a lot of research already done. There's a lot of information there. There's a lot of technology there. You need to bring it together, and also be there open-minded, not stick to the thing what you always did. Just see where can we learn from others, and that's also the goal with Zero, that we bring that back. How can others can learn from us and our experience and our journey with our project.